So today we are going to talk about emerging trends in electric vehicles. Go on to the topic. So this is what we are going to discuss today. Let me introduce myself and then my organizations. EV types, EV growth, EV batteries. That's where the means glitches and environmental aspects. This is what today's agenda. So why do we talk about EV? So everybody talks about environment, climate change, right? So and as a part of that agenda, we are also talking about EV. So, yes. So, I mean, before jumping to the topic, let me show some statistics of the from authenticated pages where we stand with respect to the electric vehicle in India. That gives you a rough idea of where we stand. So, if we aim something great, then probably we have to understand where we stand today. So, let's dig more into where we stand today. Then we will, look into how we have to move forward and decide what's our goal, etc. Yes, electric car sales in India. There is data of about 8 months, 2019 April to November. You can see there are about 1,300 electric cars are sold in Indian market in the 8 months. That is approximately 150 cars a month. Definitely, that's not an encouraging number, right? So means everybody is talking about electric vehicles. Of course, this 1,300 is that too in an Indian market with the number of cars which are selling. You might be aware. So means just 1,300 for about 8 months. Definitely, that's not a means what to say good number. And probably means I have given the link as well. So this is an authenticated data which you can very well refer that. Yes, and another interesting fact, if you look at the 2019-20 financial year, there were about 1.56 lakh electric vehicles are sold. So the previous slide is only talking about the cars. Why have stressed cars? Because most of the times, variably means invariably, when we talk about electric vehicles, cars comes to our mind. That's the reason why I have given the statistics of electric cars. Let's move on to the electric vehicles in general. So there is about 20% growth in 1920 financial year compared to the previous financial year, which is 1890. So means what is it? There are about 1.56 lakh units has been sold. So that is compared to 1.3 lakh units in the year 1890. Okay, this is except e-rickshaws. Please understand that this is except excluding e-rickshaws. Out of this 1.56 lakh in the last financial year, that is April 1st 2019 to March 31st 2020, 1.52 lakh units were two-wheelers. Let me stress that out of 1.56 lakh units of electric vehicles sold in the market, that is excluding e-rickshaw, 1.52 lakh units were two-wheelers. And it is just about 3,400 cars and 600 buses. That's put together cumulatively, it is 1.56 lakh or 1,56,000 vehicles which has been sold. As I told, this doesn't include the rickshaws. Fine. So probably then you can understand, so to say, the two-wheeler has a much bigger market than the car market. That is multiple times. You can multiply how many times it is. So probably countries like India, what to say, we also has to focus two-wheelers in a much better way than just giving what's the focus which we are giving to the cars, right? So if you look at the corresponding numbers in the previous year, that is 1890, there is this 1.26 lakh, that lakh is missing anyway, 1.26 lakh two-wheelers and about 3,600 cars and around 400 buses. If you look at this data, 1819 we have sold 3,600 cars, that has been reduced to 3,400 cars. That means 200 cars has been reduced in the year 1920. If you look at only the apple to apple, if you compare the cars, and buses, means 400 buses has increased to 600. And if you look at two-wheelers, 1.26 lakh has increased to 1.52 lakhs, where you can see a huge jump, right? Again, this is a data source is there. Yep. Let's come to the including e-rickshaws. So in the year financial year 2019, EV sales in India crossed the 7,50,000. That is cumulative. Okay, this includes electric two-wheelers of 1,26,000 and electric three-wheelers of 6,30,000. So you can see means this electric three wheelers is basically about the rickshaws, autos, etc. So probably if you look at this number, then you can really understand. Means where is our biggest market as on today, at least there. So there are about 6,30,000 electric three wheelers, and there are about 1,26,000 two wheelers, and you can see that so to say cars are of about 3,600. That's what the previous slide is also talking about, right? So you may aware of this FAME, faster adoption and manufacturing of electric vehicles. So this data is probably giving you an idea, rough idea where we stand. Yes, so I believe probably my first slide itself it's very clear. So if we talk about electric vehicle, we need not talk specifically electric vehicle as only a two wheeler or a four wheeler. So electric vehicle can be any form, right? So this link, I believe that link I have already added in the chat box or even in the comment section, which you can watch. So this is a flight which is purely powered by solar. There is no other external sources. You can call it a solar flight. So you can find it in this link. This link has been already shared to you in the text box. Probably after the session you can go back to the the video, and you can check whether it is you can watch this video. So the journey has started in the year 2015. That is attempt for the first round to round the world. That's a solar flight which has started in Abu Dhabi, and means what to say it even came to India. So means what to say that's purely powered by a solar panel. Okay, don't ask me how many passengers are there. It is only two passengers, pilot and co-pilot. But yes, that has given a rough idea of so to say even a flight can fly without any other additional sources, which can fly only through solars. Okay, though that is a research, but that's probably a great move forward in terms of even flying in the sky without consuming so to say polluting fuels, right? And again, so probably this is a very interesting slide, I believe. So means again, electric vehicles not necessarily has to be a two or four wheelers. Means as Indian statistics it says it's predominantly three wheelers, but means we should not forget. Means most of our trains are already electrified, so that's also comes under a category of electric vehicles, I believe, right? So if you take the number of passengers which are carried out in local suburban trains or passenger trains or metros, that's definitely much higher, and probably like this electric trams which you can find it in other countries as well. So I have added some YouTube link. This also I will try to post it after the session in the chat box, so you can watch a few videos related to other vehicles which are powered directly from electric, right? So this gives you an approximate background of so to say uh, which is essentially talking about we not necessarily has to focus on electric two wheelers or four wheelers. We can focus when we talk about electric vehicles, we can talk anything and everything, right? Yes. So what's the biggest challenge which so to say today's market is facing? This, why this electric vehicle, everybody is talking about electric vehicles, but the numbers are not really encouraging. Why? So there could be many reasons. The predominant reason is price. So means everybody is talking about electric vehicle, everybody is talking about pollution, everybody is talking about climate change, but who is willing to pay an additional cost? So if you take the price, approximately the price is about 2 times to 2.5 times of the conventional vehicle. So am I ready to pay by myself? Means shall I pay 40 lakh instead of 20 lakh for a car? Answer is no. Means that's from a personal perspective. So the biggest challenge has to be addressed is price. And when we talk about the price, means what is the price of electric vehicle, and this price goes to where? Means what's the specific component which occupies the most of the price? We will discuss along the course, right? So then let's talk about the charging time. Yeah, everybody expects the fact that means what to say this petrol pumps will be replaced by charging stations, and if so the case, what's the approximate charging time? So I will put it this way: the best battery available in the market is of 6C, that is the lithium-ion battery which I am talking about. That's the batteries which are probably used in the all electric vehicles. That takes 10 minutes. That takes 10 minutes to charge from 0% state of charge to 100% state of charge. So 6C battery is the best lithium-ion battery with respect to the charging capability which is available in the market. It takes minimum 10 minutes. That means if I am driving a means car or a two-wheeler, and if I am waiting in this charging station, and if I am the fourth person, probably I have to wait at least for 30 minutes to get my turn. So, am I really willing to wait for 30 minutes to charging stations? Absolutely no. Even probably in the petrol pumps where we take generally means for say less than a minute to charge, means for say put up fuel. Probably if we see a crowd of maybe 4 or 5 people, means we slightly, means our logic is to simply skip this means petrol station and go to the next petrol station for means fueling our vehicle. So in that case, means what's the uh, distance between each and every charging stations, and if there are many vehicles waiting in the queue, I mean how much time I need to wait for this charging. So that's another question. That's a big question to be answered. And the third point, I think the charging infrastructure, which I have already talked about. So means at each and every how many kilometers we are going to have this charging stations. And the last but not least, the very important point is from the safety. There are few fire incidents which we have talked about. So we will talk about that also. Right? So let's take the first point, price. So there is about 60 percentage of the cost of the electric vehicle goes to the battery. That means if I am spending about 40 lakh for a car, then about 24 lakhs goes to the battery. I mean, if somebody put the same equation and trying to compare the apple to apple with respect to the IC engine, that is the car which we are using now. If somebody says, means what to say, you need to pay 60 percentage of the cost of the car to my petrol tank or diesel tank. I mean, we used to laugh at it, but I mean, so when it comes to the electric vehicles, the battery occupies 60 percentage of the cost, and means what to say, the customer has to pay for it. And is it possible to sell only the vehicle without battery? I mean, so to say, that's the question which needs to be essentially asked. That reduces the price of this electric vehicle drastically from the capital investment from the buyer perspective, and that may motivate the market to a large extent. But in that case, means who will take the responsibility of the battery, and who will pay? Means what to say, or how does this battery manufacturing companies recovers the price? So that's a good question to be asked. I think I mean there is a concept like charging stations versus uh, let me probably yeah, let me talk a bit more on. I thought I had a slide, but not. Okay. So means what to say, when we talk about this charging stations, there are some opposite point. There is a swapping stations as well. You might have heard somewhere. I mean, to say there are some swapping stations where this vehicle can go and probably we swap the battery. That means the battery is already ready-made charged in the charging stations, and probably you can just go there and swap the batteries, right? So if that comes into the picture, then shall we means have that swapping station arrangement than the charging station. I need not wait for a longer time to charge my vehicle or charge my car. Yes, that's possible. Even if means swapping station is possible, what are the other aspects which need to think? That means what about the battery state of health, and who will invest for the capital investment? That's all probably the business world has to answer. But I mean that could be the means most optimistic way forward. If really battery comes for how many cycles, then probably that all answers the question. So now, I mean, so to say, which we probably go a bit depth on the battery. So, I mean, when we talk about this batteries, uh, the battery which I have talked about is the lithium-ion battery. The 6C battery takes about 10 minutes to charge from 0% SOC to 100% SOC. On other side, I mean, what do you see? the cost of that battery is quite expensive. So if you take about the battery, which is normally lithium-ion battery, people might be claiming that is $200 per kilowatt hour. That is for a 0.5C battery that takes approximately 2 hours to charge from 0% state of charge to 100% state of charge. That means battery will take 2 hours to charge from 0% state of charge, that is 0% that is completely dry, to probably 100% that is fully charged conditions. So that battery, yes, that might be around the market is about $200 per kilowatt hour. But if you move to, higher C rate, where if you want to charge your battery faster, then the money which you need to invest on the battery will increase. So, if you move from 0.5C to 1C and 1C to 2C, then the cost might be quickly jump to maybe $300 per kilowatt hour. And that might be, as I told, even $500 per kilowatt hour or $600 per kilowatt hour when you move to, 60. So, when we're talking about a charging time, it is just not a charging infrastructure. Many people always claim this what is it, charging stations capability or the speed at which the charger charges the battery. But it is also the battery capability to accommodate the charge is more important. So when we talk about this battery, so what's the battery which we are going to adopt and what's its cost, how much cost it comes. So that we need to really look into that. So point 1 and point 2 are very strongly interconnected. If you want to optimize the charging time, that means if you want to go with a much faster time, then probably you need to really compromise on the price, right? Fine. So is it possible to sell only the vehicle without batteries? Yes, that means business world how it evolves, that has to tell the answer in the future. But there are some possibilities. Yes, what to say, the electric vehicle manufacturer can sell only the vehicles, whereas the battery is still owned by either the electric vehicle manufacturer or some XYZ business entity. So you will be what to say, that same entity maintains this charging or swapping stations, and you will be what to say, charged for whatever may be the charges, and the cost of energy might be in such a way that that's probably to recover the cost of the battery also. And when we talk about this batteries, the lithium-ion batteries, approximately this comes for about 4,000 cycles. And again, this battery life with respect to the temperature is also another question. So generally, lithium-ion battery, people claim that this will have about 4,000 cycles. But one important aspect is that's at an ambient temperature of 25 degrees Celsius. When it comes to countries like India, mm, so the ambient temperature we know that's about 35 degree or even 40 degree, even sometimes that can go much higher than that. So then probably how do we maintain this battery at the temperature which the manufacturer is specifying? If we are specifying at that temperature, then what's the air conditioning mechanism which we need, and what's the cost of it, and if we are maintaining air conditioner, where does it get the power, and for that what's the increase in the battery capacity? All these things we need to answer, right? So let's move on to the other important point, the charging time. So as I told already, there are two constraints. Many people are talking about the constraints from the charging stations or the charger constraints. We are talking about the fast chargers, flash charging, etc. I believe, if you might have heard this video, let me quickly go on to this video.
Have you ever noticed how some people just light up a room from the moment that they walk in? Now, if you've
Do you think charging in 20 seconds is possible? Well, it's possible. After watching this video, you will say this. Recently, Indian automaker Ashok Leyland and Switzerland ABB Power Products signed an MOU to provide flash charge technology to Ashok Leyland electric buses. Earlier, Ashok Leyland tied up with Sun Mobility for battery swapping technology, and the swapping time of Ashok Leyland electric bus in Sun Mobility swapping station is 2.5 minutes. But with the ABB Power flash charging technology, the batteries can be charged in just 20 seconds. So, let's understand the flash charging technology now. ABB Power has developed trolley bus optimization, system alimentation, TOSA charging stations to recharge an electric bus battery in just 20 seconds. In the charging time, passengers can get on and off the bus. So, let's see how it works now. The electric bus batteries are mounted on the rooftop. Once the bus reaches to TOSA charging station, an automated arm will connect an ultra-fast charger to the energy transfer system on the bus rooftop in 1 second. These chargers having 600 kilowatt of power which can charge the onboard batteries in 20 seconds. That's why the technology is called as flash charging. The TOSA charging stations are connected with a grid connection along with an energy storage unit. The entire charging process is controlled by traction converters and traction motors which are equipped in the bus. Currently, there are 12 such buses operating in Geneva. For 50 bus stops, 13 are equipped with flash charging stations.
So let me stop the the YouTube video, which anyway you can watch. The link is available, and I think this video has circulated a lot in WhatsApp as well. So I believe most of you might have seen this. But you have to really understand one important aspect. So if you closely watch that, they have told it's approximately takes about 2.5 minutes for swapping, and now it is taking only 20 seconds for charging. Right? Yes. So let's go to a simple maths. Let me open an Excel sheet. So if you have noticed what is the kilowatt at which they are charging, that is 600 kilowatt, and they are charging for 20 seconds. Sorry. So if you have looked at that video, probably much more clear, or probably you go back to that video and probably listen to that video again. That is 600 kilowatt means it is getting charged on 20 seconds. So that means what's the kilowatt hour which it can charge is 600 into the seconds, that is 20 seconds. So this is kilowatt seconds, this is not a kilowatt hour, right? If I want to convert that seconds to hours or kilowatts minutes, then probably I need to divide by 60, that is to convert into minutes, and then again additional 60, that is to convert into hour. So yes, we can all appreciate the fact that that's the flash charging, that's great, but that increases your kilowatt hour only by 3.3 kilowatt hour, nothing more. Means if you know what is the battery rating which is there in the bus, then probably means you can very well understand this 3.3 kilowatt hour which is charged, that's not going to charge from 0% SOC to 100% SOC. That's a very small percentage SOC increment, or probably it's like every bus stop that will be there, that will be compensating probably the energy which is consumed from one stations to the other stations. So many people might have misunderstood that as that the flash charging is charging from 0% SOC to the 100% SOC. No, when there is a swapping station, the swapping station, your battery SOC will be already means more than 95% in the charging stations, and means if even if you are going with a 5% SOC in your vehicle, then you can probably in 2.5 minutes you can swap the battery. That means about you are gaining 90% of SOC in 2.5 minutes, whereas you are gaining only 3.3 kilowatt hour in 20 seconds. So even if you take means what say 50 kilowatt hour, that is means what say much lower percentage, that is about only 6% of the SOC which you are gaining with respect to the means that flash charging, what's the video which you have seen. So go back and watch that video, and probably try to understand the terminologies what they are using. So that's not really increasing the SOC from 0% to 100%. I believe that that's clear. So here what to say, but the advantage is means what to say, you are not charging your battery from 0% to 100% at a stretch, but each and every step you are trying to charge this vehicle. That means each and every bus stop you are trying to charge this vehicle. So whatever may be the energy which has been spent from moving from one stop to the other stop, probably you are trying to gain that using chargers when the vehicle is stopping at the next stop. So that could be another mechanism to which we can look at it. That's what we need to understand from this flash charging. Don't confuse that this flash charging will increase the SOC from 0% to 100%. Yes. So does it make a sense? So previously I was driving a diesel car or a petrol car. I felt so dirty. Now I have moved to the uh, electric cars. But shall I be proud that I am clean? So to that answer the question, how much percentage of the energy which we are getting, this comes from the renewables, that we need to really look into. So here you can see means most of the energy which comes as on today is from what say thermal power plants or something. For that, to add a quick data, I am going to another website, interesting website. There is a website called CEA, Central Electricity Authority. This website is giving a data of what's the total installed capacity in India state wise, that is as on 30th April. That means just 14 days or 15 days old data. That's directly from Central Electricity Authority. All India installed capacity as on 30th April. So you can see here, mode wise they have given the breakup, that is thermal. Thermal they are further classifying to coal, lignite, gas, diesel and total. Then nuclear, they have a hydro, then they have renewable energy sources, right? Region wise they have given north, west, south, etc. So as on 30th April, we have an installed capacity of 3,70,106 megawatt. That is 370 gigawatt is what's the installed capacity in India. Out of 370 gigawatt, about 87 gigawatt is renewables. Out of 370 gigawatt, about 87 gigawatt is renewables. So out of 87 gigawatt, about 34 gigawatt, 34.6 gigawatt from solar and about 37.6 gigawatt from wind. So if I go back and closely put what's the percentage fraction of the installed capacity, I have about 87 gigawatt installed capacity of renewables, and I have 370 gigawatt installed capacity of total capacity in India. So means renewable installed capacity is about 23.5 percentage. So means if I multiply this by 100, I will get percentage. So 23.5 percentage of the installed capacity in India is of renewables. But how much percentage of the energy which we are generating from this renewables, that's obvious, we know. Means when you have a wind or solar, means the plant load factor of solar is in the range of about 20 percentage. Even wind is also in the range of same, almost 25 or 20 to 30. It depends upon the location of the wind farms and the solar farms. But the power perspective, yes, we are great. It's about 23 percentage and it is growing day by day. But if you look at the energy perspective, that means what's the total energy consumed versus what's the total energy which has been generated by this renewables. That we need to really look into that. So let me quickly go on to the another website to find out what's our total demand in India, etc. data. So hope you know this website, Power System Operation Corporation Limited. So thanks to this COVID, they have developed a dedicated page where they have compared different demand at a different time. So let me go to the last page, right? So 22nd March, where you can compare that with the 15th March means why I'm talking about this 22nd March is because that is the means where we have India has started this Janata curfew. So you can see, means region-wise demand and all over the demand, and means you can understand. Means what to say? What's the energy consumed and how much percentage we have reduced. So this data probably means what to say gives you quite a lot of informations. On an average, it means what's the Indian demand and where we stand on different places, right? So this all probably in gigawatt hours. You can see means what there is a drastic reduction during this COVID. But it means all these things I am talking about means because I expect you to go through this numbers. This gives you quite a lot of idea of what is our average demand. Our average demand is approximately 150 gigawatt prior to the COVID. That means though we have an installed capacity of 370 gigawatt, our average demand is about 150 gigawatt prior to COVID, and means that has been reduced to maybe 110 gigawatt or 115 gigawatt of demand in this lockdown period. Fine. So now having said all this, means out of this 150 gigawatt average demand, how much gigawatt our uh, demand which I am meeting from the renewables? That's the question. So that is probably again you can refer the same CA website or probably means what to say Pusago website, or you can go to the load dispatch center websites how much renewable energy which has been generated everything. So this is a power fraction is 23 percentage, that's encouraging, but the energy fraction is probably in the range of about 11 to 12 percentage. That is because of poor load factor. So now let me quickly jump on to this my slide. Yes. So I have changed my electric vehicle from diesel or petrol to means electric vehicles, but still means the energy which is used to charge my electric vehicle, about 90 percentage of the energy comes from non-renewable resources. So that really doesn't make a sense. Yep. So then probably we need to go to another way forward. That means instead of means what to say making a pollution at city, probably I may be polluting somewhere else. That's a remote power stations or a remote rural villages. So means what to say if we have increasing the renewable penetration, just not a penetration, renewable contribution. When I say terminology is penetration, that's relevant to the power, and the contribution that's relevant to the energy. If we really increase the renewable contribution, that means how much percentage of the energy is met by the renewable resources. If we are increasing, then we can be really proud of this electric vehicles. Let's quickly take a case study of what I'm talking about. There was an example which we have done in Australia. So there is a pilot project where we have tried to means put up charging stations in the highways. So means at what distance we need to put up a charging stations, etc. That's what the assignment which when we are working out. I mean, it's about every 30 kilometers we need to put up some charging stations in the highways. That's what the results which we got. Then means what to say. Probably if you look at the countries like Australia, the geography means what to say. You may not be able to find a transmission network or a transmission systems because the country is geographically wide, and there will not be any cities or towns or villages along the highways. So this extending this transmission network along these highways are really costly. Then we thought of means having a local charging stations with the local sources. Then we have worked out a cost of that. Means what to say? Uh, Means if you are again you have to go either by diesel or probably you have to go with a combination of wind solar with an energy storage there itself to charge your batteries. So with that means what to say? If you go with a diesel, then there is no point in replacing your means the diesel engines, IC engines by an electric vehicle. If you go with the wind and solar, again you need a storage because the wind and solar is intermittent in nature. You need a battery energy storage at that charging stations. Whenever there is excess wind and solar, you need to charge your batteries. And probably means when the vehicle comes, you need to means what to say convert again back to that to your electric vehicle. So the cost is exponentially high where that is not really means made a commercial sense. So I mean we need to be a bit more clear on that perspective also. So means when we are just changing from the electric vehicle to the means battery sorry IC engine to the electric vehicle not necessarily always means what to say enhances the environment or makes the climate better. So we need to also think from this perspective how much energy which we are using to charge our electric vehicle comes from the renewables. That's another question to be answered. Right, I think with that I will stop my presentation. So let me take few questions. I'm not sure who has asked that question. What's the resale value of the electric vehicle? So it's a question of a big question. Means what to say? As we told already, we discussed what's the cost of the battery in the electric vehicle is about 60%. That means if you remove the battery, then the cost of the vehicle comes down to 40%. That means 40 lakh electric vehicle cost is only means what to say about 16 lakh if you remove the battery. So means what to say then the resale value is predominantly relevant to the state of health of the battery. So means what to say then it's not a question of resale value of electric vehicles, it's the resale value of the battery. So that's what probably means. My expectation is that rather than pushing this battery also to the customers, instead we may means what to say some other business entity may own their batteries and probably means what to say put an charges for this battery as well as battery charge, so that that might be means better technology or better business mechanism which in my view may be more realistic than means what to say pushing this battery also to the consumers. That's my view. Of course there could be different views. Yes, so we have talked about swapping technology. Even swapping technology means the swapping time is about 2.5 minutes. That might be okay for the buses, etc. But for two-wheelers or cars, still that's probably higher time than our fueling our two-wheelers or four-wheelers. And the swapping technology, the biggest drawback is, I mean, so to say, how many different manufacturers, what's the rating of the batteries, and how many batteries that swapping station has to maintain. Is it all come from the same manufacturer, or probably interoperability is going to be a biggest question when the swapping technology we talk about. So if the swapping technology has to be adopted, then probably we need to be it's more standardized battery rating with the C ratings, etc. Because there are n number of players in the market for the battery, and there are many different electric vehicles are using a different capacity batteries at a different C rate. Then in that case, means the number of batteries which the battery swapping station has to maintain becomes extremely high. That may not be a commercially viable solutions for that swapping station operators. So that's another question to be answered. So question from Mohan Kumar: will our country sell 30% of electric vehicles by 2030 as a part of E3030? What's your view? So to be frank, whatever may be the view which I say that that's just a guess. Means I don't think means what to say that number is really mandatory. So what we really need to work as a student community or means what do you say the faculties is we need to work towards how to enhance the efficiency of the electric vehicles, how to reduce the cost of the battery, how to reduce the dependency of this battery to other countries. Like it means now we are using a two-wheelers and four-wheelers with the petrols or diesels. So means mostly we are depending on Middle East countries like Saudi, Oman, Qatar, Kuwait, etc. And if we go with the means electric vehicle, then we depend on lithium-ion batteries that comes predominantly from China, Korea. So I mean, what say probably that's another trap. That's it. So means we need to really look into give us solutions from means sourcing perspective as well. And even nowadays, probably if we talk about this batteries where the lithium availability is there, that's all probably controlled by China. So that's a political decision as well. How better we are going towards in that. So I'm not going to give any figures, 30% of the electric vehicles, but I can tell you other aspect also. Means what to say? What do you mean by 30% of the electric vehicles? Is it on road or is it on the percentage sale of that particular year? If you take Norway, they have sold about 49% of the electric cars. That means out of, I mean, let's say they sell 100 cars in the year 2018, they have sold 49 cars as electric cars. That means 49% of the cars sold in Norway market in 2018 of electric cars, and that has been increased to 63% in 2019. That means 63% of the cars sold in the Norway market in 2019 is of electric cars. So probably means that doesn't mean Norway has 63% of the electric cars on road. No, only on that particular year they have sold 63%. So when we put up 30% electric vehicles by 2030, is it on road or is it means what is sale on that particular year? That's all questions. Yeah, 30% of the electric vehicles by 2030 may be possible, probably if the price is sharply decreased and means what is the either swapping stations or a charging stations or means what is it, some charging mechanism which reduces the time, and if it ensures the safety, that's what probably means all of us are working towards. So that answers, then probably 30. Why not 30%? Means it could be more than 30% as well. Yeah, another question from Mohandas, lifespan of the battery. Yeah, so probably I take few minutes to answer this question. That's a really good question. So means we might aware of different type of batteries. We have lithium-ion batteries. We have lead-acid batteries, etc. So let's start with the lead-acid battery. The lead-acid battery, what we are talking about in our means what say colleges or in a household the inverter applications, that has a calendar life of about 20 years. That has a calendar life of about 20 years, but that has a number of cycles of about 400. So, whereas if you take lithium-ion battery, the lithium-ion battery, the calendar life is only 10 years, but whereas it will come for 4,000 cycles. What I mean by 4,000 cycles, when you charge this battery from 0% SOC to 100%, and then you discharge from 100 to 0, this is one cycle. Like that, it will come for 4,000 cycles. Sorry, yeah, 4,000 cycles. This is for lithium-ion battery. So lithium-ion battery has 4,000 cycles, whereas your lead-acid battery has only 400 cycles. That is on the cycle life. Whereas on the calendar life, your lead-acid battery has a life of about 20 years. Then you may ask the question why we are replacing our lead-acid battery every 2 years or 3 years in our household. That is probably means because of the cycle life has completed. Right, so number of cycles is limited to 400. So that too, again means it depends upon the temperature. There are many things, so that's really important. Right, Milton C. What about a kilometer? It can run in 20 seconds of charging. That's what it probably means. We need to look at. I think this is relevant to that video what I have shown. I think that might everybody has seen the WhatsApp as well. So means what to say, if we are charging for 20 seconds, as we told, means what to say, it's charging only about 3.3 kilowatt hour. So for 3.3 kilowatt hour, that vehicle, how much kilometer it can means go, that much kilometer it can go. So probably, means what to say, then each and every bus stops might be probably pretty close in cities, then that might work out. If the probably this distance between two bus stops are high, then you may be means what to say, stopping time in your bus stops also has to be increased maybe to 30 seconds or 1 second. Sorry, 30 seconds or 1 minute, so that you will be able to increase the charge. Right? And Muruganand Gopal, what's the SOC percentage change from station to station? Yeah, that's a question to be answered. Means what's that depends upon what is the distance between the stations and what is the energy which that bus consumes. That I think again relevant to the same video. So what's the percentage SOC drop or what's the energy which is consumed basically? If I'm taking 100 kilowatt hour, so if I'm means increasing 3.3 kilowatt hour, then that is 3.3 percentage, and probably how much percentage which is decreasing, that purely depends upon what's the energy consumed by that vehicle. Won't be the battery life be affected when we frequently charge the batteries when the SOC of the battery is good? Yes, so this is again there are many manufacturers are giving some simulation results. If you take like Samsung or Panasonic or LG, so they have some tests again. They also have some results with respect to the um, practical tests as well as some simulation results. So they will be able to tell. When I'm saying this 4,000 cycles, that's with some standard operating this one. So you have to exactly view what is the ambient temperature, what's the rate at which you are charging, what's the rate at which you are discharging, what is your cycle, what's the charging cycle, what's the discharging cycle, what's the minimum SOC, what's the maximum SOC, what's the ambient temperature. If you give all these inputs, then probably they will be able to tell means what's the number of cycles this battery can come. Yes, you have rightly told, when the battery SOC, if you are maintaining SOC high, then definitely it reduces the number of cycles. So they call the terminology called rest SOC. So that means at what state of charge you are maintaining your battery. So that is called as rest SOC. That means if you keep higher SOC, then the life of or the cycle life of the battery definitely comes down. That's to answer question from Murgana. The rapid charging is possible. Which material is used for a battery? No. So means that's what probably means that is charging 600 kilowatt, but probably that battery may be about 200 kilowatt hour. So means your charging rate is only 3C. So means what to say? We need to look at means what to say, when we say flash charging or whatever may be the charging, we cannot go beyond the C rating of these batteries. So means what to say, 600 kilowatt means we need to ask really in that question what's the approximate what's the battery rating. If it is say example 200 kilowatt hour, then probably means that battery is charging at a 3C rate. So means as I told, the battery best battery available with respect to lithium ion as on today is 6C battery. That is that will charge from 0% SOC to 100% SOC in 10